participaram da publicação, porque depois de 4 anos, ter o material em mãos é algo muito emocionante para mim. Tá?
De fato, é muito emocionante. Na abertura, propositadamente, nós invertemos um pouquinho aqui, e eu gostaria de agora, nesse momento, chamar o presidente do nosso Conselho Estratégico, Felipe Cassol, para o seu pronunciamento, por 2 razões. Ele queria ver a apresentação do Rodrigo, da obra, e fazer uma ponte com a nossa próxima palestra também.
Olá, pessoal, tudo bem? Bom dia. Que honra, hein, Rodrigo? Que belo material, né? Eu acho que esse trabalho começou lá com o Carlos Melo e a gente está hoje aqui celebrando a nossa norma comentada. Vale ressaltar que na América Latina só o Brasil e o México têm a norma de pré-fabricado exclusiva, né? Então, tecnicamente, nosso país está bastante à frente, ou bastante entusiasmado, ou bastante dedicado a toda a comunidade técnica. Bom, eu sou o Felipe Cassol, sou presidente do Conselho Estratégico da IBRACON desde este ano, de 2022. A gente iniciou uma jornada agora da IBRACON pós-pandemia, dando muita continuidade a toda essa envergadura técnica que a IBRACON construiu até hoje. Então, em nome de todos os fabricantes e todos os associados, eu gostaria muito de agradecer a oportunidade de a gente estar aqui lançando a nossa norma comentada, poder criar esse nosso seminário dentro do Jubileu de Ouro do IBRACON. Acho que até é difícil para mim, como jovem, né, poder falar de algo que há 50 anos representa tanto para a nossa engenharia nacional. Então, eu queria agradecer a Iria por todo o esforço que ela faz com a gente pela IBRACON tecnicamente, ao Paulo Helene e toda a comunidade do IBRACON por estar nos abrindo as portas. Agradecer a todos vocês que estão aqui juntos, comunidade nacional e internacional, o AQIL, que está aqui presente conosco, é uma honra muito grande poder tê-lo. E acho que o concreto, de uma maneira geral, né, o segundo material mais consumido do mundo, a gente poder estar passando por essa jornada do concreto que representa a construção civil que representa todo o mercado imobiliário, que movimenta 1/5 do PIB mundial, eu acho que tem uma importância super relevante, e o IBRACON, como o guardião desse material, eu acho que tem uma representatividade a nível nacional ímpar. Então, é uma honra para mim poder estar aqui hoje conversando com vocês em nome da IBRACON, mas também pessoalmente, de toda a minha jornada como engenheiro, onde eu comecei de estagiário da ilha, né? Quer dizer, é um longo passo, me sinto muito jovem e muito início dessa jornada que toda essa comunidade de hoje apresenta. Quer dizer, os nomes que estão aqui hoje, eu escutei de criança, quer dizer, os trabalhos que já faziam, e hoje poder estar participando de uma maneira ou outra é super empolgante. Então, acho que a Cassol Pré-Fabricados, empresas da minha família, participou ativamente do desenvolvimento técnico, tem feito um trabalho sempre de muita seriedade, são 64 anos na empresa, mas no momento que ela, junto com outras 5 empresas, formou um grupo para defender a IBRACON, para criar um movimento em prol da industrialização, eu acho que essa hora chegou da industrialização, e nós temos aqui hoje boas ferramentas para poder agora sim multiplicar, disseminar e fazer esse assunto permear por todo o mercado. Então, eu queria muito agradecer a presença de todos que estão aqui no seminário e aproveitar nesse ímpeto e agradecer ao AQIL por ter nos aberto as suas fábricas nas missões técnicas da IBRACON AQIL. O AQIL lidera uma empresa japonesa de 7 fábricas de pré-fabricado, onde estão as grandes soluções técnicas já resolvidas do mundo, né, que é um pouco do que a gente tem aprendido. Então, já temos prédios de 40 pavimentos em zona sísmica, 100% em pré-fabricado. Quer dizer, tecnicamente, esse assunto está resolvido. A gente precisa trazer ele para a realidade, trazer ele para o nosso mercado, permear mais dentro da realização, até porque existe uma necessidade latente de industrializar, uma questão de sobrevivência, principalmente para o mercado imobiliário, que começa a enxergar isso como caminho a ser seguido. Então, aqui, muito obrigado por toda essa nossa o entrosamento entre as comunidades, e gostaria de te convidar aqui para vir para a sua palestra e nos explicar um pouco mais sobre esse novo desafio que é a sustentabilidade dentro da pré-fabricação, dentro da construção civil, de maneira geral. Desejo a todos um bom dia, uma boa programação e que a gente saia daqui mais entusiasmado do que a gente entrou. Muito obrigado.
Thank you for your kind introduction. And I have a long relation between ABSIC, and before the pandemic, they visited Tokyo. They had some mission group to visit precast concrete high-rise building construction site. And also, I attended the ABSIC meetings in Sao Paulo before the pandemic. At that time, I show you some of them. I hope remember it. But I show you the high-rise building precast technologies, as I said before. And of course, Japan is an earthquake-prone country, but even that severe situation, in order to increase productivity, we use precast concrete, reinforced concrete technologies, especially in the high-rise building. So today, I'll show you some examples. And my company has 7 concrete factories. So I'm a, practical precasters like yours. And half of the beginning the presentation, I will review yesterday's keynote a little bit. And half of the last part, I will show you some examples which we are going to start to challenge, and some of them are just idea. And I'll show you some clue as precasters against carbon neutrality of the concrete. This is the contents. And first of all, I'll show you a little bit, very briefly, about the FIB's sustainability of precast concrete structures. Unfortunately, I did not get involved in this output, so the Ilya knows much better than me. I just show very briefly. And also, I'll show you the CO2 emission, the precast concrete, and also the 2 and 3 yesterday's little review, low carbon technologies in the precast concrete of the product stage. And after that, low carbon technologies in the reuse of the precast members. It's also the yesterday's review, and including my company's challenge. Okay, so in 2018 with PCI, we launched the Bulletin 88 of sustainability of precast structures. This is very, very good state-of-the-art report. And this is contents of table contents, and they show the existing the code and guidelines and the life cycle assessment, and also sustainability aspects of precast structures. And personally, I think the annex is very, very important because they have very good EPD examples in North America, Norway, and UK. So now my company started to calculate the CO2 emission of the buildings and the bridges, infrastructures, and of course the precast concrete factories. In that case, this annex is very, very useful to disseminate my young engineers by using this material. I'll show you a little bit about the contents. So this is the sustainability of the precast system. It's well known from the span in meters, in the horizontal axis. The vertical axis is sustainability. So there are many, many types of the precast members. Depends on the span, but there are many variety of the point of view of the sustainability. And the waste, of course, you can imagine that as the construction time is longer and longer, the precast technique can reduce the waste in cubic meter. So this is the one of the advantages, which means lead to the sustainability to reduce the waste. Okay, so in the bulletin there are some trial calculation. This is a comparison hollow core slab and the cast in situ slab in the energy consumption of the production floors. Of course, the precast technique is lower than the cast in situ, as you can imagine. And this is the comparison of the different floor types in each concrete, reinforcement, and materials, and solid waste, and finally the use of primary energy. And compare with hollow core and shattering slab and the cast in situ. Of course, in this case, the hollow core precast technique is lower than in each materials volume and values, which means more sustainable. And this is the transportation. Compared with casting floor and the precast floors, the fuel by the transportation is much lower than compared with the cast in situ. But in Japan, the area is not so large like Brazil. Your country is very huge, but our countries compared with this calculation is not so big difference from the cast in situ at this moment. So I said to young engineer to please confirm, please review your result. So maybe the precast floor will be smaller than the cast in situ floors. Okay, that's the very, very brief description of our bulletin 88 in 2018. If it's possible, you can use this bulletin as a reference. Okay, so CO2 emissions. Again, I'll show you the supply chain of the construction. And mainly the precast has to reduce the CO2 in the used product stage in A1, A2, A3. And I told you yesterday that very, very roughly the CO2 emission in this stage is about 400 tons CO2 per million euro. This is the cost of the product. So this stage emits CO2 about 40% of the total CO2 emission of the construction activities. So this is a calculation which I showed yesterday, and in the product stage, by using non-clinker zero cement concrete and plastic fibers, we can reduce 70%. In concrete, 6.5 ton goes to the 1.84, which means about 70% reduction So the zero cement concrete, today's the Professor Getu's the keynote speech, and the new type of the low carbon concrete can affect a lot in the product stage. And also the reinforcement. Oh no, it's a steel strands, the tendons. It's about 50% reduction by using the plastic fibers. In this case, the aramid plastic fibers. And reinforcement. And instead of the steel reinforcement, in this case, I use glass fiber plastic reinforcement, which can reduce a lot, about 90%. So finally, in Japan, we multiply the $3,000 per cubic meter. It's a cost, everything included. So 1.3 ton CO2 divided by 3,000 ton per cubic meter, which means 430. So almost equal as 400 tons per million dollars or per million euro. So 400 tons is roughly we can use from now up to until the precise calculation method is realized in the practical field. And by using low carbon technologies, 430 can be reduced to 130 ton per million dollars. So this is very, very effective transition way at this moment. We can use the present technique. And again, I would say the green premium in the product stage, the reduction of the CO2 is about 1.3 minus 0.4 times, this time again, $150 per ton CO2, which means $135 per cubic meter. This is green premium if the carbon price is 150. I don't know the 240, 250, but this 150 is much larger than at that moment in the future. So I repeat it again and again in my company. Low carbon technologies is not free. It costs. But at this moment, it's not so easy to convince our client because they said, okay, show us the low carbon technology, but we don't allow to increase in the cost of the building something. But I hope in the near future, it's everybody's movement all over the world. The client and building and infrastructure, they will accept this green premium in the near future. Okay, again, I'll show you the future challenge in reducing CO2 emissions. And Professor Getu's keynote speech this morning, the low carbon concrete is already carbonated because pH is 11 to 12. So in this concrete, so how do we assure the durability of low carbon concrete? And he already said this morning, in the case to use plastic fiber, it's one of the solutions. I agree with him, and I'll show you the examples in the Japanese highway, non-metallic bridges. And also relations between durability and CO2 emissions, this is very important, and also the Professor Getu say the same things this morning. But as a precaster, I don't know how to get involved in this research activities. I don't know that maybe ABSIC made a fund to the university. I don't know, but sometimes this treatment come from the university, academia, and sometimes come from the consultant company. But everybody should think about the relation between the durability and the CO2 emissions. And also at the same time, the precast structures should be the high durability because of the minimizing the CO2 emission by the maintenance. And also this morning keynote, he says the CO2 absorption, we don't have any sophisticated software to evaluate this value, but carbonated concrete and present technology concrete, they absorb the CO2, but nobody knows how much the CO2 absorbed by the concrete. So this is another solution to be solved. And resilience, and also finalize the green premium. We have many, many things to challenge to solve this kind of problems. Okay, so today I'll show you a little bit detail in this platform. You are the suppliers in the precasters on the left-hand side, and by using the existing database of the cement and concrete or the steel, this data, you can get this data in your precast plant, and also calculate the emission. After that, you propose this platform in your individual precast plant, the CO2 emission. And this data will be used by designers, and sometimes will be used in the builders to minimize their design, to minimize their building during to reduce the CO2 during the construction. And finally, for example, the durability and CO2 emission, this kind of very, very difficult theme, that this data will come back to your factories. And also, if you use the high durable concrete, low carbon concrete, and sometimes plastic fibers, these new technologies data you can get through this one-stop platform by the FIB. So I think the FIB's activity is very, very advantage to the precasters, designers and builders and owners who are the members of the FIB. So I hope that this activity is going well in the future, and also that everybody can get advantage against the carbon neutrality of the structural concrete. Okay, I'll show you this database by the UK the designers in bridge. Today I'll show you the building. He proposed the same things in the buildings. And compare with the bridges, the buildings is, of course, office and warehouse, and also refurbishment. Everything is different design conditions. But relatively saying, the relation between the CO2 emission and the cost of the construction is about 400 tons per million, in this case, pond. So 400 is a very, very important value in the production stage, and also, of course, for you all, the precasters. And finally, we are going to go to this green area to reduce after the reduction of the CO2, 300, 200, and sometimes 130 I mentioned before. So this is our goal. Okay, so again, I use this chart, and the precasters think about the A1, A3 production stage. And sometimes, and maybe the FIB will launch the new data in the use stage in B, and go back to the material and the production stage. I hope this new research and development is very, very going to be useful for the precasters in the future. Okay, so I'll show you the low carbon technologies in product stage. And one thing is lightweight structures. This is matter for the designers because you can imagine lightweight means the reduction of the concrete. And this is my company's case. And we developed the butterfly structures in the superstructure of the bridge. And the behavior is the same as the double barrel truss, but composite structure is very, very complicated in the detail. So we just changed the double barrel truss to the butterfly shaped the structure by using the very, not so special, by using steel fibers. Concrete is relatively higher than the usual bridge concrete, 8 MPa, and we are rated 0.5% content in volume in the steel fibers, high strength steel, which uses the tires reinforcement wire. So the material is not so special. You can procure it anywhere all over the world. So look at this. The web is only 15 centimeter. There is no reinforcement. We use fiber reinforced concrete, and the inside of the panel, in the tension area, we use the steel tendon strands, just it. So the casting concrete is very easy. We produced this special panel in our one of our concrete factories. No reverse, which means very, very high durable members. And finally, 2013, this bridge was completed, and we get FIB Outstanding Concrete Structures as a winner 2016. After that, we already built 5 butterfly web, and also 1 butterfly web is under construction, which is the Exados bridge in Japan. And low carbon concrete, I told you yesterday. And the zero cement concrete, I show you the little bit detail today. And this is a characteristic. Compared with the same strength, we can reduce 70% of CO2 emissions. And the strength is very important to use the structure, bridges and high-rise buildings. 100 MPa, the maximum, and usually we can get more than 100. And by using ferronickel slag, it's a very special sand. We can reduce the shrinkage up to 100 micro, very, very low shrinkage. And creep is 1/3, low creep coefficient, and also during hardening, the heat generated much less than the usual concrete, 30, 40 degrees centigrade. So as a contractor, as a builder, we can reduce the risk during construction. Shrinkage and hardening generated heat, and also sometimes creep. So this is a mixed proportion of the zero cement concrete. Look at this. The water binder ratio is very small. We use less than 100 kilograms water. Professor Gettiu said, in order to reduce the low carbon concrete, the risk to make the water use less than the 100 kilogram. And we use silica fume and fly ash and blast furnace slag. And also, in this case, the right-hand side, the sand is FNS. FNS means ferronickel slag. And it's a slag, and also this slag has very, very special characteristic to reduce the shrinkage. But of course, now we are just developing the